Okay, this is Chapter 2, Notes. Actually, this is the first part of Chapter 2, which deals with the nature of matter. So we talked about earlier that chemistry is the study of materials and the changes it undergoes. Well, that material is called matter on the most basic level. And matter is something that has mass and takes up space, which should be a review from physical science. Now, like in biology, where cells were the basic unit of life, atoms are the basic unit of matter. Okay, they're the fundamental units of every element. And if you remember, elements are put together on that periodic table. So for the question, are all atoms alike, the answer should be no, because copper is an element, and its atoms should be different from the element gold, or carbon, or oxygen, or any other element on the periodic table. If they were all alike, what would be the point of the table? Okay, so all atoms are not alike. Regarding atoms, we will talk in more detail about the structure of atoms in a later chapter. What you need to understand right now is that they combine to form compounds. And compounds are substances that are made by bonding atoms together in a specific way. Bonding, just think of it like marriage, where two people are legally bound together. It's the same thing for atoms. So when atoms come together and form compounds, they act like molecules. So because they are bonded, they will act in a similar way in their bonded state. So if you look at my example, I show you that hydrogen, which is H2 for its formula, plus oxygen, which is O2, combine to form water. So two separate elements will combine in a certain ratio, H2O, and will act together like water. So you know that they're bonded because when you drink water, you can't taste the hydrogen and the oxygen separately. And if any of you are pretty sharp, you will notice that the equation that I put in this example is not balanced, but we'll talk about that later. Elements and compounds, what's the difference? Elements are substances with one type of atom. So do you recognize these elements? He, helium, C, carbon, Ag, that's a tough one, silver. So those are one type of atoms. You can tell by the simple formula. Compounds, on the other hand, are substances with different atoms, but always in the same combinations. So carbon dioxide is what you breathe out, and its formula is always CO2. If you changed it to something like CO and changed that ratio, you'd get a totally different compound, carbon monoxide. So compounds have to be in the same combination every time. So anybody, anywhere would recognize CO2 as carbon dioxide. Ammonia, which is a pretty strong cleaner, will always be in the ratio NH3. And one more time I put up on the screen, ratios will never change. Otherwise you'll get a different compound. States of matter, these probably look familiar, but you need to see it now in just a little bit more detail. So when we talk solids, my example is ice. I'm just carrying out my water example. So you know ice is a solid, right? You put ice cubes in drinks, whatever. But what I need you to understand is that they have a fixed shape and also volume. So like you can try to break an ice cube and it'll shatter, but it's tough to do so. Liquids, so my example is water, and what the difference that you see now is, yes, there's still a definite volume, but it will take the shape of its container, so its shape changes. It's not as fixed, it flows. Gases, and steam is still an example of water. Just because you change it to a gas form doesn't change what water is. So it's still water, just in a different form, and that's no definite shape or volume. So you do need to understand the states of matter in a bit more detail. Okay, what we have here now, is really the heart of this new chapter, and it's what you need to work on today once I'm finished. Okay, it's the properties of matter, how to recognize matter. There's 4 ways to recognize it. Okay, the first way is right here. It's called a physical property. A property is a characteristic of a substance. And you can see this property without changing what the substance is. And I think it's best to look at my examples to understand this. Odor If somebody's wearing perfume or cologne, they're still that person. They just smell in a different way. If somebody changes the color of their, if somebody has, brown hair color or blonde hair color, like when you look at them, you say this is the color of their hair, that's just a description and it's physical. They're still that person. Volume. If you pour water into a graduated cylinder to take the volume, it's still water. These two words right here are more chem terms. Density involves measuring mass and volume. So if you took the mass and volume of water, still water, but you measure density. If you had an ice cube, which is water, and you melted it to a liquid to find its melting point, still water, hasn't changed. And then the states of matter. If you call something a solid, a liquid, or a gas, it's just a description. You haven't changed it at all. So that is physical property. Now, chemical property. We can still see the word property, right? That's still a characteristic. But what makes it chemical now is that when you're describing something, that substance will make a change. So if you look here, if I say burning, something has the ability to be burning, anything that burns will not go back to its original shape. If any of you drive, have cars, and you don't protect the metal on your car, it will rust, right? And once that metal is rusted, it can't go back. Digestion. You eat food, right? When food goes into your stomach and it comes out, right, when you go to the bathroom, it's not in the same form as when you put it into your mouth. The food has changed. Plants. They start as seeds, right? And then they grow into flowers or vegetables, whatever. They have changed. They can't go back into the seed. Okay, but right now these are still just characteristics. So it's the growth of plants. I didn't tell you what plant is growing, just the fact that they can grow. Okay, so this is just general characteristics. Okay, two other characteristics of matter are changes of matter. So check out this. Physical change. Physical is still like a description, right? But now we have an actual change. So watch my examples. Just take water. If you melt it, or put it in the freezer, or boil it, you are changing how the water looks, right? But it's still water. Cutting. If you cut a piece of paper, it's still paper, just in two different parts or more. If you color like your fingernails or put contacts on your eyes, you still have your nails, you still have your eyes, they just look a little bit different. It's a physical change. Now here, didn't I already say solid, liquid, and gas? I did, but now this is an actual change. So solid to liquid is melting, right? So that's a change. Liquid to a gas is evaporating. So it's not just telling me if it's one of these, it's an actual change from one state to another. I thought ironing was a good example. If you've ever ironed like a shirt or a skirt or something like that, you still have the shirt or the skirt. Unless you burned it, it's still there, it just looks nicer. In carpentry, wood is supposed to be smooth when you use it, so sanding that wood is changing it, but not what the wood is, it's just changing it to make it look better or smoother. It's still wood. This word right here is the toughest for people. That is pronounced solubility, and it means to dissolve. And I put here sugar and water. Why don't you think of like coffee? If you want your coffee to taste better, you'll add sugar or cream. That dissolves in the coffee, but doesn't change what the coffee is. It just tastes better. Okay, one more, the chemical change. This is another change, and now when a change is made, it will become a different substance. So when I give you an example, I'll make sure that it is specific. So right here where it says burning, like on a test or quiz, I would say burning paper, because if you burn paper, it can't go back to its original form. Cooking. If you cook an egg, let's say you crack open an egg and you make it for breakfast, it's not going back into that egg, it's done. Steaks, they start raw and then you cook them. Once you cook them, it doesn't go back to being raw. Look here, iron rusting. Now what did I say? I said iron is rusting, and where is it rusting? On your car. Pretty specific, right? So just saying something can rust would have been a property, but the fact that iron is rusting on your car has changed. Fermentation. This is the creation of alcohol, right, to drink. So a lot of alcohols start as grains or fruits. So wine is coming from grapes. When the grape ferments into wine, it doesn't go back to being a grape. It's done. It's already wine. Digestion. I will say like digestion in the human body. Once you eat something, you can't get that food back in its original form. It's gone through your body and changes into a different form. This last one is the one people find the easiest because anytime chemicals are mixing and you recognize a chemical name like an acid or a base, salt and water, you just assume that that's chemical. And it is. Okay?